domain and range of a relation. So first is find and second find number of relations from A to B. I'm interested in the second answer. To get that second answer, first answer should serve as a hint. First answer I will give you. The first answer is 6. This question we have already seen in the last class. The number of elements. N of A is cardinality of set A 2, cardinality of set B is 3. So cardinality of A into B will be 6. 2 multiplied by 3 is 6. Tell me what will be the number of relations from A to B. Or type EXP in the chat box if you don't know. Yes, very good, Sanat. So this is what A cross B looks like. So A cross B cardinality is 6. This much was clear from yesterday's class. Now number of relations. Now number of relations, if I tell you how to find, means relation is what? Relation from A to B. Relation is any subset. Now actually what I'm asking you is number of relations mean any subset. So actually what I'm asking you is how many subsets can you form of this given set A cross B. So if I tell you to form a subset, you can form some null set also is a subset. So yes, this is a relation from A to B. This is a relation from A to B. You could also form a subset like a, let's form a singleton set. Singleton means consisting of only one element. Let's say 1 comma A. Okay. This is also a relation. You could have also formed a singleton set like 2 comma B. This is just one single element. This is also another relation. Or you could have taken some other combination. What other combination? Let's say a subset consisting of 2 elements. Let's say 1 comma B and 2 comma C. And lot many things are possible. So this is one relation This is another relation. This is third relation. This is fourth relation, fifth, sixth, and so on. How many? How many? So do you realize that number of relations from A to B is equal to number of subsets of the set A cross B. A cross B itself is a set. Okay. So whether I'm asking number of relations from A to B is same as asking number of subsets of the set A cross B. If you realize this, so you can see that this answer will be equal to 2 to the power 6, because we have the relation. In set theory, we have seen this formula that if cardinality of some set is, let's say, 5, so the number of subsets, how many subsets are possible? 2 to the power 5. I've given this formula to you. Do you remember? So cardinality of A cross B is 6. So total number of subsets will be equal to 2 to the power 6. Is this explanation clear?
Yes, sir.
Okay. So if this property is clear, so the generalization we can write over here. If cardinality of set A is equals to P and cardinality of set B is equals to Q, then the number of relations possible from set A to set B, from set A to set B is 2 to the power PQ. The cardinality of A cross B will be PQ and total number of subsets will be 2 raised to PQ. This property should be clear. Now, moving ahead, R is equals to set of x comma y such that x plus 2y is equals to R. Find cardinality of R and represent the above relation using arrow diagram. If you are able to find cardinality of R, write it in the chat box. No, Sanat, wrong. No, Makrand wrong. No, sorry, Makrand right. Makrand's answer is right. Makrand sent private messages. Chat in the chat, change the setting to change send the private message so that others don't know.
Oh, sorry, sir. I didn't
Okay.
see that.
Method here is not to write all the elements one by one and then count to find the coordinate. That is not the correct approach. Dhananjay, USB, getting. Okay, let's see. This will not take that much time. X plus 2y. See, x belongs to A, y belongs to B, and the addition x plus 2y is odd. Observe here x plus 2y. If you want this to be odd, don't go by trial and error method. That sir, I will take one, I will pair it with one and see whether the addition comes out to be odd. I will take one, pair it with two, and check whether the addition comes out to be odd. Two here, the element two I will pair with one. I have two here, I will pair with two and see whether x plus 2y is odd. This such pairings, it will take a lot of time. So just observe that whatever is the value of y, irrespective of the value of y, this 2 times y will always be even. So now x plus whatever put you value of y you give, x plus an even number, this should be odd. So can you conclude that my x should be odd number? X can never be even. My x should definitely be an odd number, so that my odd plus even, this gives me odd. So this is my conclusion that sir, x should definitely be an odd number. So now if x is an odd number, so what do we have about y? We see that sir, what was our original argument? Our original argument was, so you give any value to y. Any value to y, the 2y will be even only. So means x should be odd, give any value to y and it will suffice. X should be odd and y equal to anything. or instead of anything, you can write y equal to no condition. So if this much is clear, x should be odd and y equal to no condition. So now x can be equals to what are the possible values, sir? X can be 1, x can be 1, x can be 3, x can be 5. Only 1, 3, 5 will get paired up. With whom will they get paired? With all the elements in B, because there is no condition on y. So I will, in the arrow diagram, I will just draw. So cardinality, if only cardinality is asked, if only cardinality are, you should write cardinality of R is equals to 3 elements of A and 4 elements of B. 3 elements of A and 4 elements of B, and they are all combining with each other. So 3 multiplied by 4, that is 12. This is the cardinality, and the arrow diagrams, A will get 1 will get connected to all 1, 2, 3, 4. 3 will get connected to all 1, 2, 3, 4. And then 5 will get connected to all 1, 2, 3, 4. Okay. This is the arrow diagram on the question. Is this clear? Okay. Solve this question. Okay, sorry, I should write here this condition. If I just write x plus y square equal to 65, lot many values will come. I should give you this condition. X and y belongs to n. X and y both belongs to n. Buddha Harinis, are you getting this?
Yes, sir.
Did you revise yesterday's lecture? Did you see the video? You were absent yesterday.
Yes, sir. So, but yesterday's lecture was not sent in the group, no, sir.
It's not sent in the group yet.
Yes, sir.
Yeah, it's not sent up till now. It will be sent today. If you have finished solving, write done in the chat box, because if I'm not getting any response from you, I think that you are unable, you're still trying it. So I'll just keep waiting from my side. Sanat, is it done?
Yes, sir.
So write the answer here. I'm waiting for your response. I think you're still trying it. X plus y square equal to 65. So now what the coordinate of r will be 8 here. How to solve? X plus y square. X and y both are natural numbers. So don't start from x. Instead of starting from x, start from y. Means if you take suppose sir, x equal to 2, for example. If you take x equal to 2, then y square will be equal to 63. And then y will not be a natural number. So how to proceed then? So just think sir, x is positive, we know that. Because we know that x is positive, it's a natural number. So our conclusion will be y square. Y square is equals to 65 minus a positive number. 65 minus a positive number. Therefore, y square is definitely less than 65. And y square is a perfect square. So y square is a perfect square. So y square either it was less than 65 and a perfect square. So it can be either 64 or 8 square. 7 square is 49, or less than that 36, or maybe 25, 16, 9, 4 and 1. So correspondingly x will be equal to what? If y square equal to 64, x will be 1. Here if y square equal to 49, x square will be 16, right? Yes, correct. If y square equal to 36, x square will be 29. If this is 25, then y square will be equal to 40. This is 16, so y square will be equal to 49. This is 9, so 56. X square, y square equal to 4. This will be 61, and here it will be 64. But be careful that 1 will not get paired up with 64. 1 will get paired up with y, not y square. So 1 will get paired up with 8, 1 will get 16 will get paired up with 7, 29 will get paired up with 6, 40 will get paired up with 5, 49 with 4, 56 with 3, with 2, with 1. So the total pairs, that is the total pairs, are 8. Cardinality will be equal to 8. Is it clear, everyone? Okay. Now, moving ahead, domain, range, and domain, codomain, and range of a. So what is domain? Let's say first two non-empty sets A and B, and R is a relation from A to B. From A to B, it's a relation from A to B. So domain of R, domain of relation it is there. Okay. So domain of R, domain of relation bolo. You can say domain of relation or you can say domain of R. Domain of R represented as this much. Domain of R is equals to set of those elements A belonging to the first set. Now R is a relation from capital A to B. So set of those elements belonging means those elements of A such that A comma B belongs to R for some B belonging to B. This is the formal definition. So in rough language, if I tell you, that is means you pick up those elements of A which actually form an ordered pair. Means set of those elements A belonging to capital A such that A comma B belongs to for some B. Means it should form a pairing with some element of B. So set of all first elements of the ordered pairs in R. This is the rough definition. Set of all first elements of the ordered pairs in R. Similarly, now range of relation R. Range is the opposite of this. Range is of this equal to R. So I don't know how the short form of range is written. So range of relation, I think it's written range of R only. Is equals to set of those elements small b belonging to the capital B, means a set of elements of the second set such that A comma B belongs to R for some A belonging to capital A. Means in the second set take those elements which have actually form an ordered pair. So that is set of all second elements of the ordered pairs in R. So I will leave some space for codomain.
One scroll down, sir.
Okay. Written the definition. Domain is a set of first elements. Range is a set of second elements. Done.
Yes, sir.
Okay. Now illustration. let's say A is equals to 1, 2, 3, 4, 5, and B is equals to, what should I say, PQ RS P. PQ RSP. Consider R1. R1 is equals to, let's say, 1 comma P, 2 comma P, 3 comma S. So that's it. So domain of R1, what it will be? Domain of R1. So when I'm talking about domain, see, first of all, realize that R1 is a relation from A to B. It is not a relation from B to A. So R1 is a relation from A to B. So domain of R1, so concentrate on the set A, the first set A, and take those points which have actually formed an ordered pair, which have actually formed a pair. So whether one has formed a pair, yes sir, one has formed a pair. So I will include one in my domain. One has formed pair. Whether two has formed a pair, yes sir, two has also formed a pair. So two also I will include with me. Now along with whom they have formed a pair, that is not important. It is not important, sir, one has also formed the pairing with P, two has also formed the pairing with P. So should we include them or not? That is irrespective. We do not bother about it. One has formed the pair, two has formed the pair, and three has formed its pair. So we take these three elements and that's it. This is our domain. 4, it has not formed any pair. It has 5 has not formed any pair. So they will not be included in our domain. So domain of R1 is just set of elements 1, 2, 3. Range of R1 will be what? Range of R1. The set of second elements. Set here at a set of second elements will mean actually the elements of the set B. Set of elements of the set B which have actually formed an ordered pair. So P has formed an ordered pair with 1. Q has formed formed a pairing. R has not formed any pairing. S has formed its pairing. So P and S. This is range. Is this easy? Let's say now suppose in this case only if I tell you R2 is equals to 1 comma P Q 1 comma R 5 comma P. So can you see domain of R2? What will be domain of R2? Domain of R2 is a set of all first elements. In the ordered pair also you can come in the ordered pair also just pick up the first elements. Those are the actually which they have formed the pairs 1 comma 5. Now here 1 comma 5 is not an ordered pair. Okay, this is a set. Domain of R2 1 and 5, they are the elements of the set. Okay, and range of R2. Range of R2 will be the set of second elements of the ordered pair. So PQR. P comma Q comma R. PQR, pick up the second elements in the ordered pairs. That will be the range of R2. Is the concept of domain and range clear?
Yes, sir.
Okay. Harini, take the screenshot quickly. Done. Now codomain is what? Codomain is very simple. If R is a relation from set A to set B, okay? R is a relation from set A to set B. This second set is called as the codomain. That's it. Codomain of R. Set B is called as the codomain of R. Set B is called codomain of R. Set B is given a special name codomain. A is not given any special name. Okay, now why it is so I don't know. A is not given any special name. Okay, the complete set B will be the codomain. So here, if I tell you this is the domain, you have to find range. You can find what will be codomain of R1. Codomain of R1 is obviously set B only. Codomain. If I tell you, it will either write complete B. You can just simply write the letter B or write the all the elements. Codomain of R2 will be equal to set B only. Nothing new. Okay. Is this clear? The meaning of domain, codomain, and domain, range, and codomain. So now, if I tell you this property, don't put the mic on mute. Afrin, put the mic on.
Yes, sir.
Now, if I tell you, if R is a relation from set A to set B, then first domain of R is a subset of set A. When I'm telling you this, am I teaching you anything new? If I'm writing this property, domain of R is a subset of set A. Do you realize that this is it's very clear. Because domain, how we are forming the domain, we are picking some elements from A. It is not necessary that all the elements of A will form the image. All the elements will form an ordered pair. So it is not necessary. So domain of R is the subset of A. It may be equal to the complete set A also, but domain of R will definitely be a subset of A. And second, range of R. Range of R is a subset of set B. It may be equal to complete set B also, but even if it is equal to the complete set B, still we can say that B is a subset of B. So range of R will be a subset of the second set, that is set B. Or I may also call this thing, the second property only, equivalently, I can also call this. It is the same thing I'm writing. Range of relation R, any relation is always a subset of codomain of that relation. What's new in that? Range of relation is a subset of codomain of that relation. So is this thing you should keep in mind. Okay, and now some terminologies means this how to read and read these things. Relation, when I tell you to write the this arrow diagram is a relation. Okay, arrow diagram is a visual representation of a relation. This relation can also be called as a mapping. Whether you call it as a relation, means it is not a good word to say R is a mapping. I mean, a relation is a proper mathematical word. You can also say that this arrow diagram which is there, R is a mapping from set A to set B. R is a mapping from set A to set B. Relation bolo ya mapping bolo, it's one and the same thing. Secondly, the ordered pairs that are formed, for example, here, this example that we see, R1 is a relation from set A to set B, 1, P, 2, P, 3, S. Now this relation, the ordered pairs which are there, how to read this thing? 1 and P. 1 is P, the set P, sorry, not the set P, the element P. The element P is image of element 1. Element P is image of element 1, or you can say that element 1 is pre-image of element P. Are you getting it? First set के जो elements है, those are pre-images of the second set elements, and the second set के जो elements है, those are images of the first set elements. Means obviously if they are actually paired up. In case of R1, you cannot say that P is the image of point 3. P is not the image of point 3 because 3 comma P is not present only in R1. Okay. So if they are paired up, if actually they are paired up, this can also be stated as 3 comma S is a pair. So you can say that S is the image of point 3 or 3 is the pre-image of point S, of element S. This is just the mathematical terminology to read that thing. Okay. So now this was the part of domain, range, and function, domain, range, and codomain. So let's also solve some questions related to this. How many questions? 3. Find domain of R, range of R, and codomain. Forgot to mention the condition. X and Y belongs to natural numbers. But don't write this condition. Infinitely many X's and infinitely many Y's will be there. X and Y both are natural numbers. In the chat box, you will write cardinality of R, answer. Just simply write an integer. Cardinality of R. How many elements will be there? Come on, students, give the response. Cardinality of R in the chat box. I'm waiting for the answer. Harini, is it done? Pujita, wrong. Sanath, write the answer in the chat box. Cardinality. Sanath, the cardinality answer write in the chat box. No response. Okay. R equal to set of xy, x plus 3y equal to 17. See now x and y both are natural numbers. X and y both are natural, and x plus 3y is equals to 17. Know that x is a positive natural number. So we have 3y. We have 3y is equals to 17 minus x, means 17 minus a positive number. So 3y should definitely be less than 17. And y is natural number, so 3y is a multiple of 3. 3y is definitely a multiple of 3 and less than 17. So 3y can be what? Either it can be 15, 12, 9, 6, 3. That's it. 0 will also do, but 0 for that y won't be natural. So if 3y is equals to these values, what will be the value of x? 17 minus corresponding value. 17 minus corresponding value. So it will be 2, 5, 8, 11, and 14. So actually x will not get paired up with 3y. X will get paired up with y. What is the corresponding value of y? The corresponding value of y is 5, 4, 3, 2, 1. So that's it. My relation R will look something like this. 2, 5, 5, 4, 8, 3, 11, 2, and 14, 1. So domain of R is equals to 2, 5, 8, 11, and 14. Range of R is equals to 1, 2, 3, 4, 5, and codomain of R. Codomain of R is a set of natural numbers only, the second set. and cardinality of R. Cardinality of R is equals to 5, number of elements. Why did it take so much time? Okay. So this is the concept of domain, codomain, and range of a relation. Now let's move on to functions. Now, after this, functions, don't miss any classes of functions, I want to tell you, because functions is a very, very important chapter in your boards and IIT, especially for IIT. So when I will be taking about the domain and range of functions, that time don't miss the classes, okay? One more sum. Pujita, one more sum you want? Yes. Let's say A is equals to less than 10 and P is equals to set of natural numbers. X belongs to A, Y belongs to B, and the condition is domain, codomain, and range, and find cardinality. No, Pujita wrong. Cardinality is wrong. Yes, Makram, correct. Okay, Pujita. What about others? Dhananjay, nowadays no response from you. Harini, Harini B, are you able to solve? Harini B, are you able to solve? The first element X belongs to set A. How is the set A looks like? Set A is set of prime numbers less than 10. So prime numbers less than 10, it will be what? 2, 3, 5, 7. That's it. This will be my set A, and set B is a complete set of natural numbers. Now what he's telling, that X is such, X and Y are such that X should be from set A, means out of this 2, 3, 5, 7, and that it will get paired up with which natural number? X will get paired up, means 2. If I tell you 2 will get paired up with what? 2 will get paired up with those natural numbers which should be less than X, means it should be less than 2. If X equal to 2, Y should be such, means the natural number should be such that it is less than 2. So 2, there is only one natural number along which 2 will get paired up. Let's say X is equals to 3. So 3 will get paired up with 2 also, and 3 will get paired up with 1 also. Do you see this thing? Then the second element should be less than the first element. That's it. And second element is obviously a natural number. It belongs to be, therefore it's obviously natural number. Okay. 5. 5 will get paired up with how many numbers? It will get paired up with 1 also. It will get paired up with 2 also. It will get paired up with 3. And it will get paired up with 4 also. And 7, if I tell you about 7, if you take X equal to 7, can you see that 7 will get paired up with 1, 2, 3, 4, 5, 6? So this complete is my relation R, which will look like. Here, these are actually 6 elements. I have not written that thing. These are 6 ordered pairs, 7, 1, then 7, 2, then 7, 3, and so on. Is this clear how the relation R will look like? So domain of the relation, domain of R is from the set A, those elements which have formed an ordered pair. So those elements which actually have an image. So we observe here that all the elements 2, 3, 5, 7 have form a pairing. So 2, 3, 5, 7, all of them have form a pairing. So this is a case where the domain of R is complete set A, complete set A. Codomain of R is a set of natural numbers only. Codomain of R is a set of natural numbers. Range of R is equals to 1, 2, 3, 4, 5, 6. Okay. Range of R is this elements 1, 2, 3, 4, 5, 6. All these previous elements are already included. And cardinality of R. Cardinality of R. Can you see the cardinality of R is equals to 13? 2 get paired up with one element. 3, if x equals to 3, it will get paired up with 2 elements, 2 ordered pairs more. 5 will get paired up with 4 elements. 7 will get paired up with 6 elements. 6 plus 4, 10 plus 3. That. Let's take one last sum. The same thing. Find domain. Range. And there is a very high chance that you will commit a silly mistake. In the chat box, simply write cardinality of R. How much it will be. No, wrong. Pujita, wrong. No. Codomain is obvious. Codomain will be Z. I'm interested in cardinality. If you get the cardinality correct, means you have solved it correct. Z is a set of integers. Okay, you realize this thing. All positive, negative, all the integers. What about others? No response, only Pujita and Makaranda replying. Harini B, Dhananjay, Afreen, are you understanding what is going
Yes,
on?
sir.
Yes.
Are you able to solve this question?
Yes, sir.
And what's the answer? And what's the answer? You're able to solve it. Just give the answer in the chat box here. Have you finished solving? No, Pujita wrong.
Sir,
See, one thing you keep in mind that here, one response that I got, that's a domain of, no, still it is wrong, Harini B. Okay, so see, x can never be equal to 21. Pujita, that mistake which you have committed in the chat box, which you wrote the reply. X equal to 21 and y equal to 4, sir, or let's say y equal to 2. That will be wrong because x cannot be 21. We have x square addition y square should be 25. So you will have to take 21 square, you will have to take. So maybe you got that answer because you were thinking, sir, x square equal to 21. X square equal to 21 and then, sir, y square equal to 4. Okay, but that may be possible. That will satisfy this equality equal to 25. But the problem there will be x will not be a natural number. If x square equal to 21, sorry, x will not be an integer. So how to proceed here? X square plus y square is 25. X square plus y square is 25. Now here, since x and y both are integers, first of all, we are not dealing with complex numbers. So x square is also positive, y square is also positive. In complex numbers, x square may turn out to be negative also. Here we are, z is a simple real number only. So integers, z is integer, integers are real numbers. So both x square and y square both are positive. So we have that, sir, x square should be less than 25 or maybe equal to also, because y square equal to 0 is also possible. Y square also less than or equal to 25, and also and x square y square are perfect squares. Do you realize this? Because since x and y are integers, so x square y square are perfect squares. So we do not have to bother about x square being greater than 25. X square is a positive number, positive or better than positive. I should say non-negative. Instead of positive, I should say non-negative. I will write here positive, or let's say 0, positive, or let's say 0. Non-negative is a better term. So worry only about those perfect squares that lie from 0 to 25. Nothing more than that. So perfect squares between 0 to 25, if you just see this, you can see from Pythagorean triplet. that x square plus y square equal to 25. Sum of two squares, sum of two perfect squares equal to 25. So this will be possible only if 9 plus 16 is equals to 25. That is 3 square plus 4 square is equals to 25. This is the only case that you have studied in school. And here, because 0 is also allowed, one more possibility is acceptable. Perfect square 25, perfect square 0, that is also allowed. That possibility is also allowed. Perfect square means 5 square, perfect square 0 is the perfect, so 0 square. So this possibility is also allowed. Now, how to assign values to x and y? So here first concentrate on this triplet, means this 3 square plus 4 square equal to 25, that is 5 square. So is it necessary that x will be equal to 3? Means I want x square equal to 9. So if x is equals to 3, x is equals to 3, then y may be equals to, if x equals to 3, x square is equals to 9, so y square. Now y square I want to be 16, so y may be equal to 4, it may be equal to minus 4 also. X is equals to minus 3, same case, y can be equals to 4, y can be equals to minus 4. Is this clear? So but why are you taking x to be equal to x square to be equal to 9 only? X square can be 16 also, means instead of pairing 3 comma 4, you could have also paired 4 comma 3. So that is, if x is equals to 4, then y could have been 3 and minus 3. But instead of x is equals to 4, why are you taking x equal to 4? X could be equal to minus 4 also. If x equal to minus 4, y could be 3 or minus. So let me write separately only for counting purposes. Otherwise, again, you will confuse. Minus 4, y can be 3 or minus 3. So here, do you see 8 ordered pairs I have got? This is not the final answer. This is the 8 ordered pairs. 3 comma 4, 3 comma minus 4. But when you're taking 3 comma 4, 4 comma 3 is also another pair. 3 comma 4 and 4 comma 3, they are totally different. We are talking about ordered pairs. They are not same. 25 and 0, if I come over here, x equals to 5 if you take, y will be 0. X equals to minus 5 you take, y will be 0. And there is no such thing as plus 0 and minus 0. X equal to 0 if you take, y will be equal to either 5, or you can take y equal to minus 5. So here there are 4 ordered pairs. So total, can you see that domain of R, cardinality of the relation, 12 ordered pairs, is it visible to everyone?
Yes, sir.
Domain of R. Domain of R will be 3 is also forming an image, minus 3 is also forming an image, 4 is also forming an image, minus 4 is also forming the set of first elements. Okay, the set of first elements, x comma y, x comma y. 3 minus 3, 4 minus 4, 5 also there, and 0, sorry, 5 and minus 5, minus 5 is also there. 5 minus 5 and 0. Range of R, I think it becomes same only as domain. Range is again 4 minus, so range is again set of second elements. So y 0 is there, y equal to 3 and minus 3 is also included, y equal can be 4 and minus 4 also, and y can be 5 and minus 5 also. So this is the case where domain and range turned out to be same. Codomain is the set of integers only. Codomain of R is equals to the second set complete, that is the set of integers. Cardinality we have already seen. This will be my answer. Is it clear?
Yes, sir.
Okay. So we'll stop over here today. The next class, we will start with functions. I request you all, do not miss the class on functions. It is very important. The concept of domain and range of functions, that's very, very important. Thank you, everyone.
Thank you, sir.